The human brain? It's the command center of our body, a 3-pound universe nestled within our skull. A symphony of electrical impulses, it orchestrates every thought, every feeling, every action. From our first breath to our last word, the brain is the conductor of our existence. When the music of our minds fades away, the true essence of life resides in the intricate network of neurons within our brain. Understanding the brain is a journey into the core of what makes us human. The brain, in its constant activity, is a hungry organ. It requires a constant supply of oxygen and nutrients delivered through a network of blood vessels. When this supply is disrupted, the brain's delicate balance is thrown into disarray. Brain cessation refers to the irreversible end of all brain function. This means the brain is no longer capable of sustaining the body's vital functions like breathing or regulating heart rate. This state is what we medically and legally define as death. It's important to distinguish brain death from other states of altered consciousness, like a coma. In a coma, there might be minimal brain activity, but the brain stem, responsible for basic functions like breathing, may still be functioning. Brain death, however, signifies the complete and irreversible loss of all brain function, including the brain stem. Understanding the concept of brain cessation is critical in modern medicine. It helps us make informed decisions about organ donation, end-of-life care, and the ethical use of life support technologies. The human brain is a marvel of evolutionary engineering divided into distinct regions, each with specialized roles. Think of it as an orchestra with different sections working in harmony to create the symphony of life. The cerebrum, the largest part of the brain, is responsible for our higher-level thinking, language, memory, and personality. The cerebellum, located at the back of the brain, coordinates our movements, balance, and posture. And then there's the brainstem, the unsung hero that controls our most vital functions, breathing, heart rate, and blood pressure. Each region is essential. Damage to any part can lead to specific impairments. However, it's the brainstem that holds the key to life. When the brainstem ceases to function, the body can no longer maintain essential life functions, even with artificial support. Understanding the interconnectedness of these regions helps us comprehend the cascading effects of brain injury and the finality of brain death. The brain, for all its complexity, is remarkably fragile. It relies on a constant supply of oxygen-rich blood. Deprive the brain of oxygen, even for a few minutes, and the consequences can be devastating. Oxygen deprivation, also known as hypoxia, is a leading cause of brain damage and death. When blood flow to the brain is interrupted, such as during a heart attack or stroke, neurons begin to die within minutes. The initial response is a cascade of electrical failure. Neurons, starved of oxygen, can no longer communicate effectively. This leads to a loss of consciousness, and if the deprivation continues, the cessation of vital functions controlled by the brainstem. The extent of brain damage depends on the severity and duration of oxygen deprivation. In some cases, the damage may be localized, resulting in specific neurological deficits. However, prolonged deprivation can lead to widespread cell death, ultimately resulting in brain death. Section 5, the final curtain. Defining and diagnosing brain death. Brain death represents the irreversible cessation of all brain function, including the brainstem. It's a profound and irreversible state, distinct from other conditions like coma or vegetative states, where some brain activity might persist. Diagnosing brain death is a rigorous process, following strict medical guidelines. It involves a series of clinical tests to confirm the absence of brainstem reflexes, such as pupillary response to light and the gag reflex. Doctors also look for any underlying reversible conditions that might mimic brain death, such as drug overdose or severe hypothermia. Once these are ruled out, and the clinical tests confirm the absence of brain activity, brain death can be declared. This declaration has profound implications. It legally and medically defines the end of life, even if the heart is still beating with artificial support. This understanding is crucial for organ donation, allowing for the transplantation of organs from individuals declared brain dead. The clock ticks on brain failure timeline after cardiac arrest. When the heart stops beating, cutting off the supply of oxygen-rich blood, a cascade of events unfolds within the brain. This timeline of brain failure after cardiac arrest is a race against time, a battle for survival at the cellular level. Within seconds, the brain's electrical activity begins to slow down. Consciousness fades and the individual collapses. Minutes later, neurons, starved of oxygen, begin to die. The damage spreads rapidly, affecting different brain regions. After 5 to 10 minutes without oxygen, irreversible brain damage is likely to occur. The brain stem, responsible for vital functions, starts to fail. Breathing stops, and the body can no longer regulate its own temperature or blood pressure. While there have been remarkable cases of resuscitation after prolonged cardiac arrest, the window for intervention is narrow. The longer the brain is deprived of oxygen, the greater the risk of severe and irreversible brain damage. Echoes of consciousness, lingering brain activity after death. The concept of brain death, while scientifically sound, often clashes with our emotional and spiritual understanding of death. This clash is further complicated by recent research suggesting the possibility of lingering brain activity even after clinical death. One such phenomenon is the death wave, a surge of electrical activity observed in the brain moments after the heart stops. While the exact nature and significance of this wave are still debated, some researchers speculate it might represent a final burst of communication between dying neurons. Other studies have shown that certain genes normally involved in brain development become active again hours after death. This unexpected activity raises intriguing questions about the processes occurring within the brain as it transitions towards death. It's important to remember that these findings do not challenge the definition of brain death. The observed activity does not equate to consciousness or awareness. However, they do highlight the complexity of death and the need for continued research into the brain's final moments. Life support and ethical crossroads, the weight of brain death. Brain death has revolutionized organ transplantation. It allows for organ procurement, offering life to those in need. However, it raises profound ethical dilemmas. Families struggle with withdrawing life support. The heartbeat and chest movement can create the illusion of life. Misdiagnosis, though rare, adds complexity. Rigorous protocols minimize this risk. Open communication is essential. Clear explanations and empathy help navigate these decisions. The undiscovered country implications for medicine and beyond. The human brain, with its billions of neurons and trillions of connections, remains one of the most complex and enigmatic entities in the universe. Understanding when and how the brain stops working is not just a scientific endeavor. It's a journey into the very heart of what makes us human. Brain death, while a well-defined medical concept, continues to challenge our understanding of life and death. The possibility of lingering brain activity after clinical death, the ethical considerations surrounding life support, and the philosophical questions about consciousness and the soul, these are all areas ripe for exploration. As we delve deeper into the mysteries of the brain, we're likely to uncover even more surprises, challenging our assumptions and pushing the boundaries of medical knowledge. This ongoing quest for understanding is a testament to the enduring power of human curiosity and our unwavering pursuit of knowledge, even in the face of life's ultimate mystery. Wait for the continuation. Stay curious.